Good day, everyone. My name is Felix Hartanto. I'm the Business Development Manager from Draga, Singapore. We are a subsidiary of Bouygues Construction from the International Building Department or Bouygues Bâtiment International. And today I'm going to present to you our achievement in Singapore to build the world's tallest residential building, which is built with the concrete PVC, the Clement Canopy. So a bit of the description about the project. The site area is a 13,038 meters square, 2 towers, 40-story, residential, 505 units, 1,866 PVC modules. The GFA is 45,633 meters square, 100% reinforcement concrete PVC, and it's the world's tallest at the moment, with the contract period of 36 months. The commencement date was on the 1st June 2016. So what's the PVC concept of the Draga Singapore? So the first one is the need of the 3C teamwork. Client, consultant, and contractor to work in the same direction in the delivery of the PVC from the design stage all the way to the execution and the construction on site. So upfront design development is very important because for PVC, you need to get the design ahead to be approved and to be decided in order to kick off for the procurement and for the fabrication of the PVC module. So it's a factory production line and the construction at the same time. It's multi-coordination between the factory and the project site, as you're going to have a RC module production yard. Then after that, you need to manage the second construction site, which is the fit-out factory, where you do all the M&E works and also the internal finishing. And the third one is you need to manage at the same time as well, is the real construction site, which is the project site of the Clement Canopy. Well, it's a Lego style installation process, so you're gonna see later on how we stack the PVC module and to install it to become the high-rise building. It's a clean construction site compared to the conventional method of construction. High quality product because it's being done at the factory, and as well it delivers with a shorter construction period and high productivity. So I will start with the architectural presentation of the Clement Canopy. So this is the site planning of the Clement Canopy, and it shows on the third story of this development. So where you can see there are 2 towers, block 1 40-story, and as well a block 2 40-story, surrounded with the landscape and the ancillary facilities. So this is the typical block plan of the block 1, where you see that one floor we have a 6 apartment units with the 5 types of the unit. And with this, there's total 862 PVC modules at this tower, with the 70% of PVC area. So you can see on the color, this is the type of the PVC module that we use for this block 1. So we move to the block 2, where you have 7 unit core with the 8 units types. And for this block, we have 1,004 PVC modules. And you can see it with the different color and the different type of the PVC model. So if I zoom in into one apartment unit, this is an example. So it's a 2-bedroom unit, a small one, with the consists of a 3 PVC module that we join together to form one unit of the apartment unit. Now we move to the structural design of this Clement Canopy. So if you can see, once we receive the architectural layout, we define which part of this apartment can be done using the PPVC module. As in Singapore, there's a requirement that 65% of the superstructure GFA has to be done using a PPVC. So this is the 3D layout. You can see most of the apartment unit using a PPVC module, except for the bigger unit with the bigger living room. We, instead of using a PPVC, we use a full precast slab, which is done on site as well, instead of using a PPVC. Because of the flexibility, we need to do it in precast instead of a PPVC module. So the core of this apartment per floor is still done using a cast in situ for the lift, for the common lobby, and as well for the staircase shelter. So if I cut the top of this PVC module, you can see the layout of the unit at this typical floor plan. So if I zoom in for one example, this type of unit, the 3-bedroom unit, 92 square meter or 990 square feet area of the apartment unit. So this unit formed using 4 numbers of the PVVC module. So if you see at the far end is the master bedroom, which is one PVVC module consists of the master bedroom, master bathroom, the aircon latch at the back of the master bathroom, and the balcony at the front of the master bedroom. The second module you can see is the common bathroom, and as well connected to the some portion of the corridor and the master bathroom, as well the continuity of the aircon latch. The next module you can see as well is the common bedroom and connected to the wet kitchen. And the last module is the living room plus the balcony living room. So what is the main characteristic of the typical PVC module of Draga Singapore? So this is our typical design type of the PVC module. It's what we call a 6-sided RC PVC module. So the floor slab comprises of the RC floor slabs spanning across the shortest span of the modules or the beams. A balcony and aircon latch is also attached here, will be a cantilever from the main structure. RC walls, so comprises of the RC walls located on the 2 long sides of the modules. Then the ceiling is the RC ceiling flat slab, is provided for waterproof and as well for acoustic. And so this RC PVC module is pre-finished in the factory following the requirement of the COP on buildability 2015. And this PVC system developed by the Draga Singapore is particularly suited for building projects as it provides the robustness on the structure and enhanced durability. So what is the consideration of the selection of the modules? So first important is the size and dimension of the modules controlled by the transportation constraint, which is the road width and the clearance height and the crane hoisting capacity, which I will elaborate further later. PVC modules should be rectilinear in the shape, and PVC wall thickness should be uniform and standardized. PVC wall within each module should be aligned. So modularity, modular design concept is very important in developing this PVC module. So in terms of the tower robustness, so the tower is being designed and capable of resisting notional design, ultimate horizontal load, and the structural ties such as horizontal ties are achieved and vertical ties complied with. To be more sure and to be confident on the performance of all this design, so we did several different types of the tests on the prototype load test. So we did the compression test, bending test, and as well shear bond test. So now we move to the next chapter, which is how we fabricate this PVC module and how do we install it on site. So first of all, I would like to highlight that the PVVC tolerance has a higher tolerance compared to the standard government in Singapore requirement on the tolerance in terms of verticality, squareness, concrete cover, cross-section dimension, opening size for door and window. As well, if you go into the architectural, for floor evenness, wall evenness, and squareness. So having said that, with the higher tolerance requirement, definitely PPVC deliver the higher quality in terms of the performance of the end product. So how do we build PPVC? So stage one, at the RC carcass fabrication, so we cast the 2D precast panel, which the next step, we form this 2D panel to become a 3D module using a jig as a form of this 3D module. Then once we cast the 3D module connection from the 2D panel, we transfer it to the one area to cast the slab, the bottom slab of the PVC. After curing and the strength is sufficient, then we will deliver this RC PVC module to the fit-out factory using a low bed trailer. So once we receive this RC carcass at the fit-out factory, we are going to arrange the module based on the arrangement exactly the same as this unit arrangement at the project site. So we establish a steel platform and we identified the location of each of the module to form one apartment unit. So once we set all the level and the alignment, we start the process of the fit out, starting from the M&E installation, first fix, second fix, then we install the kitchen carcass cabinet, we install the wardrobe cabinet at the bedroom, as well we install the balcony railing, we install all the window, we test the water tightness of the window, we did the full tiles at the bathroom, and when all the fit-out works has been done properly, is also followed by the in-process inspection by the respective staff to make sure that each of the steps is properly done according to the requirement of the authority of Singapore. Then on top of it, in Draga Singapore, we have the quality team who's going to do a quality check prior to the delivery of the module to the project site. One thing important is once the inspection all done, we need to do a layer of protection. So we do the protection for the internal finishes, as well we do the protection for the external of the module itself before the delivery to the project site. So the next stage with the stage 3 is the site installation. So once we receive the module on site, there are two options that we can do. Either we install it directly to the respective location at the tower, or we can store the module at the temporary storage area and we are going to install it the day after. So on site, we will have two independent teams. So one team on the ground to do the preparation of the lifting gear, check the stability of the frame, lifting frame, and so on. One is being checked by the lifting supervisor. So the module will be lifted up using the heavy-duty tower crane. And once the module reaches the top at the respective location, there will be another delivery team who's going to receive this module to ensure that the module is installed at the right location with the right alignment, with the help of the surveyor and the supervisor standby at the respective location. So once the module is installed, so we need to bond them together. We need to grout the gap between the module to make it combine and become one element of the structure. So the step 4 is the grout mixing and the quality test. So before we can use the grout, we need to do several rounds of the test to make sure that the grout is appropriate before we pour it to the gap. So we need to do a sieve test, flow cone test, density test, as well to get the result from the compressive test of the grout. So To do the grouting for this Clement Canopy PVC module, we have three steps. The first steps is the grouting the gap between the module for the 1/3 of the gap between the two PVC module. You see on the picture on the right, highlighted with the orange color. So that's the first steps of the grouting, 1/3 of the total height. The second step is we are going to go to the 2/3 of the second one, which is the 1/3 height of the wall of the PVC, and we will have some whip hole to make sure that all the bubble is dispersed out, and as well that once the grout is flowing out from the gap, from the hole, from the whip holes, we understood that is fully grouted. And the last one is to fill in up to the 2/3 of the height of the wall. Then after that, we close it with the protection to prevent any rain or foreign object to enter into the gaps. All right, so the question is, you may ask, is how do we ensure the integrity of the grouting between these two walls once the grouting cement is set? So we do the pulse echo testing after 28 days curing to verify any defects or delamination on the grout between the two modules. So now I'm gonna share with you the experience time lapse how we built the Clement Canopy from the bare ground to the completion of the tower. So 1,866 module, and we install it in 1 year time from April 2017 to April 2018. So, what are the benefits of doing this PVC module? First is environmentally friendly. Definitely less dust, less noise, and less vehicle trips on site. You can see on the picture on the left. So, the comparison between the DSPL PVC method versus the conventional method. You can see visually straight away the difference on the tidiness of the PVC construction site. And on the right, you can see most of the fabrication works is carried off off-site. That's why it's more environmentally friendly, less wastage, and is better. The second benefits is regarding the health and safety. Less risk exposure to working at height, more work done at the ground level at the factory, shorter duration of the working at height, because there will be only lifting process, and less safety hazards in the work area. The next benefits is a higher quality. Since the product is being done at the factory, in the proper manner of the factory production line, so the quality is much better compared to the work done on site. This is the thing that we can assure. It also brings the higher productivity. So with the estimated about 40% productivity improvement compared to the conventional construction method. Clement Canopy, from 36 months, we managed to bring ahead by 5 months from the initial client's TOP inspection target. So, of course, benefit comes with the challenges. What are the challenges? The first one is the site and the factory management. We have 3 sites, like I mentioned, to be managed during this PVC production for the Clement Canopy. The first one is the carcass factory. the concrete module factory, which is in Malaysia. And we need also, once the module is done, this will be delivered to the fit-out factory in Tuas area in Singapore, where we do all the internal finishing and so on. And once this one is done, we will send it using the low bed trailer to the project site at the Clement Avenue 1. In terms of logistic management, so there's a limitation in Singapore to bring a big material using the low bed trailer. Not so much on the length, but there's a limitation on the width. Up to maximum 3.4 meter. It's fine to use the low bed trailer without the escort. Otherwise, you need to pay for the escort. It's a special delivery, and it has to be done at a certain time of the day. In terms of the height, it's limited to 4.5 meter, which is the height of the overhead bridge all over in Singapore. Special equipment. So when we started the Clement Canopy, it's a challenge to get the heavy-duty tower crane in Singapore because none has been done. It's not familiar. We need to get from the special supplier of tower crane from Liba. Why? Why do we need that? Because the module weight is 26 to 31 tons. And so we need to get a heavy-duty tower crane at 48 tons, where we can bring up every single module, about 15 minutes per module for lifting and installation only, and we can achieve about 10 to 12 modules a day per tower crane at this project site. So how to be successful in PPPC project? Having a good builder, this is the most important requirement. The contractor, the builder must have a strong design team to design properly the layout of the building, the modularity of the PPPC module, the connection system. It has to be designed properly. The builder must have a good project management system who understand how to run 3 different sites, which any problem at each site is gonna have a chain reaction to the next one and so on. And it's gonna jeopardize the whole construction schedule of the project. So the builder should have a good SOP, standard operation procedure. They should have a professional and reliable project team. And they should have a proper test and inspection system in place. Now I'm going to share with you how it looks after the final of the Clement Canopy. Well, that would be the end of my presentation. Thank you for the opportunity to share this prestigious PVVC project and the beautiful development.